Okay, so let's start. Let's get back to the point we were yesterday. So yesterday we were able to do a very simple example using using SQLite in Python. So we both did just like a demo, and today we're going to integrate that into Flask. That is what we have done so far. Just to recap, yesterday we follow a set of steps that are very well defined in the slides. Just to recap, first of all, the first step is always to define the SQL query that we want to execute over the database. Defining such SQL query is basically like writing a string with the query that we want to execute. It changes in case we want to set parameters or that we want to set specific attributes that will then count in the execution of the database, such as in this case, where we want to insert into translations or that we want to execute this query that inserts into a table specific values given by us, and what changes is this syntax in which we use placeholders. Then once we have defined the query, the next step, so the step 2 is defining the query. The next step is to execute such query, but for doing that, first of all, we have to connect with the database. In this case, we said we're going to use a SQLite database, which is basically represented as a file. So it's a file within our project. So to connect to the database, in this case, we just have to reference the file that represents the database. In this case, example.db is the name of the file that represents the database. And the connection is basically done through this code line, SQLite 3 connect. Once there, we create the cursor that, as I told you yesterday, is like the session that we have within that connection. And once we have the cursor, that we initialize the cursor object through this line, we execute the query. And in case the query, like in this example, that the query requires values or that the query has defined placeholders, we insert the values that we are expecting to pass into those placeholders. So for instance, here we were trying to execute this query that was expecting 2 placeholders. We can think of placeholders like function parameters. So we were expecting these 2 placeholders, which means that at the moment of executing that specific query, we have to insert or to specify or to pass the specific values for this query, okay? And then we execute. There is a case we haven't seen so far, but is simple. It's more simple than this one. It's easier. And it is the case when we execute a select, no? Because when we execute a select, we are getting something from the database. In the case of insert, we're doing some modification in the database. In the case of the select, we are getting something. So how are we going to deal with the data that is coming from the database? We basically can use one of these 2 functions, one of these 2 methods. The first, as its name indicates, is when we want to get one record from the database, when we are getting just one row from the database. So in that case, to access that data that we have fetched from the database, we use fetch1, and in the other case, we use, in case we were, for instance, getting all of the users in the database that were born after this date, for instance, in that case, we might be expecting more than one result. So in that case, to iterate over all the possible results that we might be getting from the database, instead of using fetch1, we use fetch all, okay? We will see an example, so it is more clear. And finally, the last steps concern committing the changes. on the database, to save or commit the changes on the database by running this command, this instruction, and finally closing the connection. Okay. Here is very important not to forget to commit, because we might be losing the data if we don't commit the changes that we are executing on the database. And finally, first we close the cursor, that, as I told you, is kind of a session within the connection, and finally we close the connection. Okay, so if you take a look at the slides, I designed the slides as a set of steps that are very easy to follow, and in this case, dealing with the database is kind of a recipe. So many of the things is just like copy-paste and changing or adapting what makes sense to what you specifically need. Okay, so questions? Nice. So let me try to show you an example. Okay, let me see. Okay, so for instance, in this case, what did it change in this example? I created a new query, and this query is not anymore inserting something, but I'm trying to retrieve information from the database. I did like the most simple query possible, that is getting everything, all of the fields, all of the columns within the users table, all of the rows within the index table. And in this case, everything is the same. I still have to connect to the database, I still have to get the cursor, and I still have to execute that specific query. In this case, that I have to execute the query, as you can see here, I don't have any placeholder. I might have a placeholder here. I might have something like, for instance, where something like where name equal something, question mark. Okay, so even in this case of selecting something, it is possible to use a placeholder, but in this case I don't have any placeholder. So because of that, when I execute the query, I just indicate what is the query to execute. And then, since in this case I'm expecting to get or to retrieve or to fetch more than one record from the database, the method that I use to get the results or to fetch the results is fetch all. If instead of doing a query like this, like select all the users, I would have used something like select the user where ID equal X, then in that case I would be expecting to get just one record. And in that case, instead of using fetch all, I would be using fetch one, okay? That's basically the difference. That is what I've shown here in this slide. This one, when using a select, this one retrieves the next result, just the first result, and this one retrieves all the remaining results. Meaning that let's try to execute this one. So in this case, for instance, you can see that I'm printing all of the records that I got from the database, okay? So in this case, well, I printed the only record that at that point I have in the database. Let's suppose that instead of getting all of the users, I'm doing some kind of filter or applying some kind of filter to this select query. So it would be something like select everything. I assume that you know the syntax of SQL, the SQL syntax, but just to recap, or if it is not clear, this one selects all the columns in the table, okay? From Aula, where so there in the back, can you see is it clear? Or should I zoom it a little bit? Yes, no? Okay, so in this case, for instance, I'm doing a query, a select query with a placeholder so that I can get the user whose ID is equal to a value that I will pass to that specific query, okay? So since I'm declaring here that I will use a placeholder, a parameter value, what does it implies? It implies that here, at the moment of executing the query, I have to pass a value for that query. Why do I pass the value in this way with this syntax? Because the value that it is expecting, that the query is, that this function is expecting as a value here, must be a tuple, okay, And this is the specific syntax to declare a tuple in here, okay? Okay, so this is both. Okay, and there is something that changes in this case, no? What should I have changed when executing this query? How many records I'm expecting to retrieve? 1, no? Because if I'm trying to get the user with a specific ID, I know that at most I might be getting 1 user. I won't be getting more than 1 user because each one has the ID as the primary key. So I won't find 2 records with the same ID. So at most, I am expecting to get 1 record from the database, to fetch 1 record from the database. So in that case, instead of fetch all, what I will do? Fetch 1, okay? And in that case, he retrieves me the only user that he got from the database. Okay, is it clear how it works? Questions? Okay. Let me check if I have something else to. Okay, so the next step here, since we already know like the basics with the database, how to connect, how to get data, how to insert data into the database, what do you think the next step is? To integrate this with our mobile application. So far we have been dealing with data, but with fake data, as you have done in the lab, no? That you create like a list within the Python application, and we pretend that list to be data that our application is dealing with. But of course, we know it's just like an array that we have inserted there. And we also know that is data that when we close the application and when we reopen the application is lost. We don't have that data anymore. So here, the real solution is to create a database and then to connect our application with that database so that we have all of the data that our application will be dealing with into a separate component, okay? And as I told you yesterday, once again, I want to remind you that in real life, I mean, here we're executing everything locally on our computer. In real life, it is not like that. The database and the application server is usually in a remote location, okay? Okay, so let's try to integrate this with what we had done so far. Okay, I think the last time that we did something with Cheposto was here, so Okay, so far our application is this one, right? And as I was telling you before, the data we're dealing with is fake data because it's like this dictionary that we have created within the Flask file, but it is just in memory. It is just like a list within the Python application. Okay, so our task would be to represent this information not anymore as a dictionary here, but as data into a database. Okay, into a table, into a database. Let me. Okay, let's keep it simple because I was thinking that maybe one thing we could do is try to do the whole database design, because before starting to implement something, we have to make all of the database design and try to identify all of the entities, identify all of the information that each entity will be dealing with. But in this case, what we will do, just for the sake of doing the first example, is assume, or we already know that we will have a tutors table. So let's try to replicate that tutors table on the database. And once we have to replicate the tutors table in the database, we can think of more entities and we can think of the relational design of the database. So first of all, we have the tutors list. And do you remember how did we create a new database with what we saw yesterday? So we had our SQL browser application. And by using the SQL browser application, here we will create a new database. Where are we going to save this database? In the same folder of the Flask project. So, well, in this case, is material. And I'm going to save this database as imparato. Okay. Nice. So we already have our table. For now, we will create our tutors table. We already have our database. We will create the tutors table. And we are going to add the same fields that we had in our file that were fake, but that basically give us a structure of which are going to be the data that we want to represent for the tutors entity. So here I will have ID, name, surname. Okay, so the ID is an integer, is not null, will be the primary key. We want it to auto-increment and, well, also it's unique. Then we have the name that we want to be not null. We want all of the tutors in our database to have a name. Auto-increment no is not a primary key because we already have a different field for the primary key, that is the ID. And do we want it to be unique? Does it make sense to make that field unique? No, because if we have two tutors with the same name, we want both of them to be recorded in the database. So in this case, it doesn't make sense to use the unique constraint. Let's create the surname. We had this presentation, well, that is like a quote. Okay, here for instance is a nice question. How are we going to represent the subjects that a tutor can provide or that a tutor can assist. Are we going to represent them with a field like this one? What's the, yeah?
Another table for just example.
Okay. Okay, why another table? Why do it come to your mind that maybe another table would be an option?
The table of the user can be linked to a foreign key to something.
Sure. And but I mean that approach compared to this one, why that one might be better?
Maybe I can retrieve all the teachers of a certain subject.
Okay. Yeah, for looking for the tutors that belong to a subject might be more practical in that way, but also because of
Because if the course in the future will change the name or subject, but the base is always the same, we need only to modify one row instead of modify other rows.
Sure, of course, that one it's super powerful because if something changes, if this, for instance, this one used to be Introducción a la Aplicación Web, then it changed its name. If I had this course saved as a string within each record of the tutor, then that change would have impact on all of those records in which that course was. So instead of doing that, if I have a separate record that points to this one, would be, of course, more practical. And also, because with this schema, what I'm imposing is that each tutor can have assigned how many courses? Just one, no? Do we want that each tutor might just teach one single course? Or we want to give the option that maybe a tutor can have assigned several courses? I think that the second option would be more realistic, no? Or at least we don't want to impose each one to have just one course, or that they can teach just one course. But instead of that, we can have a relation one-to-many. And that relation one-to-many in SQL is achieved by creating a different table, and from that table, pointing at the user, okay? Is it clear what I'm saying? Okay. So just because of that reason, we won't add yet this field, okay? Then we have and here is another interesting question. This reviews number, that is like the number of reviews that the user has got so far, or like a rating that the user has got so far. So are we going to represent that rating as a field? Maybe here is not that clear what I'm trying to say, but a general rule with SQL, and I want you to take this, to remember this, to have this very present, is that if there is information that I can somehow compute with the data that I already have, I don't create a field for saving that information. So if, for instance, there is a rating field, if I want to compute the rating that a user has got based on his reviews or the comments that the other users have left in their website, if I can compute that information based on the data that I already have in the database, then I don't create a field specifically for saving that record. But instead of doing that, each time I compute the record, okay? So doing things such as creating a field named average, for instance, is not correct. It's not a good practice in SQL. Or creating a field named well, yeah, average or accumulated points or number of reviews or number of is wrong because it's data that I can compute from other data that I already have in the database. Is clear the concept? Okay. So in this case, I won't add this review number because it's something that we will be able to compute based on information that we will find in a different table. For sure, in a different table, we will have comments or reviews or something like that that will point to our user. So by taking a look at that table, we will know how many comments have been left to this user. Or by taking a look at that table, we will be able to compute what is the average rating of this user. So in that case, we won't store that specific value into a different field, but we will compute it each time we will need it. We will need it. Okay, and here we have the profile image. And how do we save the profile image? What kind of data is the profile image? It is, huh? Because the image is different, no? There is one option that is a blob that is for saving the image within the database, okay? Anyway, okay, yeah, so that's one option. And which other option do we have? As a sequence of bytes, something like that. Yeah, that is kind of the blob idea. Ah, yeah, or decoding the image. Yeah, translating the image into a sequence of bytes and then saving all of the sequence in there is what you mean. Okay. Okay, that's a technically feasible solution, but there is a major issue with that, and it is that the database manager is not built and is not designed for dealing with images. No? So each time that a user wants to retrieve an image, it would be a huge load for the database to have to retrieve the whole image and a big resource such as an image to each user. And let's think that, for instance, the image is a high definition image or a high definition video or a high definition document. So the database function should be not to deliver such kind of heavy resources, but the function of the database is more than anything to find information, to check, to perform the queries, and we want to keep the database light for that kind of operations. And as I have always told you, we have always to think of this as an application that might be used by thousands of users simultaneously. So if thousands of users simultaneously are trying to download from our database the images and are trying to reconstruct from the database the images, this option, let's say, is not technically feasible. Okay, so instead of that,
So what is the step that we save the image as we did with Flask, store the similar reference?
sure. So in the database, and this is also super important, in the database, we never save the image, we never use the blob type. Instead of that, what we do is we save the path to where the image is located, okay? So as we have done with the example we did last time, we save the path to the image. We save the location of the image. So that when the user requests from us, let's say all of the information of the tutors, we give him all of the information, we pass him the path of the route, and he downloads or gets the image from a different location from where that image is saved. This is consistent with our architecture, and as you can see here, that's the reason why we have this file system, because we are not saving the images directly into the database, but we have a different file system from where the images can be downloaded. And in the database, we just store the path to where the image is, okay? And also because this file system is a component that is optimized for dealing with images, is optimized to dealing with the downloads, is optimized to dealing with the requests and that kind of stuff. Well, I was just going to show you that in real life, for instance, a cloud service that for providing that file system functionalities is named Amazon S3, and it is like a cloud service that has many locations around the world where we can save all of our resources so that the users of our application can download the images or all of the different resources from different locations in remote servers around the world. Okay? So the approach is always that one. We save the image in the file system, and in the database we keep the path to that specific image.
Companies need to manage massive industry with Amazon S3. Management features enable you to organize your data, control.
So with all of this information, we save this profile image as text. And we say that do we want all of the users to have a profile image? Will it be mandatory to have a profile image? This is a design decision that we can take. If we set this field as mandatory, then what we are expecting from the users is that when they register, they have to provide a profile image. Do we want that, or do we want to leave the option that they might upload or not a profile image? I think it might be better to ask a profile image, no? Since this is a tutors page and that we will be contacting someone, maybe for safety reasons and that kind of stuff, would make sense to require a profile image when creating the profile. So let's set this one as not null. But I'm doing these questions because I want to convey you the message that all of the design decisions that we make here are design decisions that we make upon the requirements of the application that we are building. Okay, so it's not something technical, but it is something practical. And it depends on what have been told us to implement. So in this case, since in my application I want some behavior from the users, then I decide to represent this specific field in such a way. Okay, so it is not a rule. It is not that always that we have an image, it must be a not null image. But it is because of the requirements of my application and the way I want my application to behave. Okay, so just to keep it simple, we will create the tutors table just with these fields, and well, let's see what happens. So here we have tutors. And I think it worked, so now we will close. Okay, maybe I have this viewer that I show you yesterday that is like a viewer that enables us to visualize the database within Visual Studio Code. But from what I've been seeing yesterday and today, sometimes it doesn't synchronize so quickly. And for instance, here I have already created the database with the table, and here is not still showing the data. So if this happens to you, then you can always check with the SQL browser, and you can always open the database here. To check that it is working and that it has been saved, like the tables and the data that you have created so far. So when I open it here, I can see that I have the table tutors. I swear here it says tutors. Okay. Because this one seems to be okay, no, sorry, here is, okay, so here is tutors. So here it shows me the two tables, and here it shows me the information within those two tables. So we had our application like this, and here, for instance, let's start with this one, for instance, with this function that is simple, with this root that we had so far, no? So we had in our application that under this path and this location, we have the associated tutors function, and we want to render the template tutors that received as parameter the tutors that were declared here as a dictionary. How do we want to change this function now that we know that we have databases and that we can store the data into the databases? We want the tutors to be shown there to be the ones that are stored into the database. Do we all agree? So we don't want to pass the dictionary anymore there, but instead of passing a dictionary, we want to get the records that are stored in the database and to pass that records as the ones that we will be retrieving. So with what we have learned so far, what can we do? We could be doing a copy-paste of this, no? So we already know that we have Python code that is useful for connecting to a database and retrieving information from the database. So we are now going to integrate this into Flask. Flask at the end is always Python. So let's try to integrate step by step. So the first thing here is to import SQLite here, since we want to get all of the tutors, we don't set any condition. And we are still missing the 3 final steps. So our application is already running, and here when I come to tutors, okay, it is still showing the ones that I have in the dictionary, but here in the console, let me oh. Okay, because this I did Flask run, but I run without the debug, so all of the changes were not reflected. Oh. And here, of course, is not here, but into a different import. Because we are not importing SQLite from Flask, but we are importing like a different model, okay? Okay. What was the error here? That here I didn't change the name of the database, but I left the example one. So instead of example, I said imparato. That was the name of the table that we set before. Here, for instance, when you set a wrong name for the database, he tries to create a new file for that wrong name, okay? But this one is not useful. So here we have imparato. And now that I run tutors, it retrieves me the tutors that it has in the database. So far, we don't have any tutor, so it retrieves an empty field, okay? But now I know that I'm getting them from the server, yeah?
Is it a good idea to use the same connection for all functions?
No, we use the connection just once for each request, because we don't want to leave the open connection to the database. But we just open the connection, get what we want, and we close the connection. Always because of this reason of scalability. Because keeping each connection consumes resources on the server side. So we don't keep want to keep a connection to each of the clients open all the time, but just specifically when we want to retrieve something from the database. Okay. Okay. So far we are getting the tutors from the database, but we still don't have any tutors. So let's do this. Okay, so what did I do now? I created just a new page for the registration. So my proposal is, since the last week we saw the forms and we already know how the forms work, so let's create a form. With that form, we will be able to collect all of the information of a new tutor that is trying to register in our platform. We will save that tutor in the database, and then we will check into the other page, in the page we were implementing before, that the registration is successful. Because then when we go to the tutors page, if we see that our tutor has been registered, then we have completed like the whole cycle of creating a form, submitting a form, using the data fetch from the user to send the data into the database, storing the data in the database, and then in a different function, retrieve that data in the database and show it in the graphical interface. Okay? Is it clear what we are trying to do? Perfect. So, okay, if you want, let's take the break now, so that we become more awake, and then we will implement the whole functionality. Okay? So let's take 15 minutes. See you here. Yeah, 15 minutes.